Sat Shri Akal, students. So today we will discuss all the concepts and formulae related to work and energy. First of all, what is work? So students, work is said to be done when a force is acting on an object. Let's say this is a book. I apply force on a book, F. As a result of the force, the book is displaced by a distance of, let's say, S. So after some time, the book comes here as a result of this force. So I say work is done, and work done is equal to force F multiplied by displacement S. We can also say work done W is equal to, what is the unit of force in SI system? Means international system, Newton, into what is the unit of displacement? Meter. So I get the first formula, W work done is equal to Newton into meter. If 1 Newton force displaces an object by 1 meter, let the distance be 1 meter and let the force be equal to 1 Newton, then the work done is said to be 1. Any student?
Yeah. 1
1,
joule.
1 joule. Beautiful. This is the SI unit of work accepted all over the world, joule. Now students, sometimes the work is not done. Let's say this is the wall. I'm applying a force, no matter how much Newton force I apply, but the wall is not moving. In this case, the work done is 0. Another thing, there is positive work done and there is negative work done. We have done the work on the book, in this case is positive. Let's say I take the example of negative work done. Work done is not a vector quantity. There is no direction for work done. Rather, it's a scalar quantity. A scalar quantity only has magnitude but no direction, right? Very interesting to see. Force also is a vector quantity, has direction. Displacement is also vector quantity, has direction, but their product is a scalar quantity. All right. In later on classes, you will understand that work done is a dot product. What is that? To be learned in the later classes. Dot product is always scalar product. Let us take the example of a negative work. Students, let's say you are having a car. Okay. Now let's say the car is moving. Okay. So the car is moving, let's say in this direction. Now you want to stop the car. What do? You apply brakes. Now the force of the brake is acting in which direction? In the opposite direction. This is the F of brakes. Am I right? That's why after some time the car stops. The velocity of the car becomes 0. So students, this force which is acting in the opposite direction to the direction of motion. Positive direction is the direction of motion. F brakes. Force because of brakes is acting in the opposite direction. Here the work done is negative. Again is equal to force, but force is negative N2, but force has been applied over some displacement or some distance in one direction. Distance in one direction is displacement. So if I use the word distance, you understand it as displacement. Negative force is being applied over a displacement as is the negative work done. Students, work done can be positive, it can be negative. Work done in this case, when displacement is not there or when force is not there, in either of the cases, the work done is 0. Right. We have defined what is work done. Now students, work can be done only if there is energy. Right? Without energy, work cannot be done. Like if a person has fever, he his he can do less work. He becomes weak. His muscles are not able to generate energy. So energy gives work. No energy, no work. What are the types of energy? Students, we have heat. Very after a lot of debates and after a lot of understanding, it was Joule, scientist Joule, who proved that heat is also a form of energy. And hence, the unit of energy as well as the unit of work done both were named after him, Joule, which is equal to Newton into meter, 1 Newton into 1 meter. Another types of energy are mechanical energy. In mechanical energy, students, we have potential energy and we have kinetic energy. I'll just explain in detail. Then energy can be rotational energy because of the rotation of the body. We can have nuclear energy, nuclear bomb explosion and all. We can have electrical energy because of the passage of the current. Electrical energy does most of our work. You know, it drives the compressor, it drives the fan, it gives you cool air, it drives the AC, you know, it keeps you comfortable, it drives fridge. So electrical energy does a lot of work. We are in Punjab, it gives you water, it works as a pump also, it does energy, lot of energy, lot of work done in lifting the water from ground level inside the ground to the level of the fields. So there are so many types of energy. We have muscles energy also in our body. Okay. Now, whatever is the type of energy, students, the unit of the energy is also joule. How do you define energy? Energy is nothing but, students, the capacity to do work is known as energy. Right? Sources of energy you have already understood. Right? So capacity to do the work is basically energy. Now students, interesting things. Let us say there is a person, he is doing some work. He is doing some work. Maybe, let's say there is a stone, you know. So let's say he pushes the stone to this position. Simple as that. He pushes the stone to this position. In this process, the stone gets some velocity, maybe very less. So in that way, the person, when he is doing work, when the person is doing work, he loses some energy. And the object on which the work is done, it gains the energy. Gains the energy means the energy becomes more of that object. Once again, whenever work is done, student, work is not done in the air. Work is always done on objects. ठीक? आप मिट्टी निकाल रहे हो, work is done. आप किसी चीज को ऊपर कर रहे हो, work is done on that object. ठीक है, आप इंजन आप गाड़ी चला रहे हो, इंजन इज डूइंग वर्क, इट्स एक्सेलरेटिंग योर व्हीकल. आप साइकिल चला रहे हो, नाउ इंजन इज यू, आप काम कर रहे हो. वर्क इज ऑलवेज डन ऑन द ऑब्जेक्ट्स. व्हेन द वर्क इज डन ऑन ऑब्जेक्ट्स, द पर्सन और द ऑब्जेक्ट, it can be a car doing work, it can be you doing work, it will lose the energy, and the object on which the work is done, it will, yes students, it will gain the energy. It will gain the energy, right? I wish it doesn't happen. When a bomb is exploded, the bomb loses its nuclear energy, and all the surrounding, they gain the energy in terms of heat, and this total destruction. So I wish these students become great, but they work in a way that, you know, energy is tapped for the benefit of human race, not for destruction. I'm giving a message to you students. So energy gained, energy lost is energy gained. Energy lost by someone is energy gained by someone. This gives us an idea that energy is basically transferable. Means energy is interconvertible. Interconvertible. So you have a topic, interconversion of energy. Here I will explain what is kinetic energy and potential energy. So see students, the mechanical energy, these are mechanical energy. Kinetic energy and potential energy are both known as mechanical energy. What is potential energy and what is kinetic energy? Students who don't know, please listen very carefully. Kinetic energy is possessed by a body. Possessed means, like we say, you know, the girl possesses a very good, intelligent brain. That boy possesses the quality of playing very good football. Possess, hona, kisi cheez ka hona. Kinetic energy is possessed by a body because of its, any student?
Motion.
Kinetic,
Velocity.
because of its motion. Very good. Because of its speed. Because of its velocity. Okay, only difference between velocity and speed is velocity is scalar, no direction, like a snake going in this direction. This is speed. But a bullet going in a direct straight line, we say this is velocity. Both are having same units, meter per second. How much distance is covered in how much time? That is the unit of both, same. But velocity is vector, speed is scalar. Only magnitude, no direction. Velocity, magnitude as well as direction. So kinetic energy of a body is because of motion. So like, let's say one of our students starts running. It starts running in the morning. It's doing jogging. So at that time, as long as she's doing jogging, I can say that she's having kinetic energy. At any time, I can measure the kinetic energy of the girl. How? Half into mass of the girl, not weight, mass into whatever is the velocity of the girl, square of that. That can give you kinetic energy at that moment. Kinetic energy at that moment. So when velocity changes, kinetic energy also changes. When velocity goes down, kinetic energy of the person also goes down. When velocity is increasing, the kinetic energy also increasing. All right. But there's no linear relationship between velocity and kinetic energy. In fact, kinetic energy, let's say, is y, and velocity is x, m is constant. So we can say it is, if velocity is x, y is equal to x square. right? So it will not be a straight line when we draw it on the graph. All right. So kinetic energy, we understood. What is potential energy? Students, potential energy of a body is because of its potential, because of its position. For example, you are having a book. Let us say it is lying on the ground. Well, everything in this universe is relative. Let us assume that the ground is at height 0 meter, right? Let's say we start measuring height from the ground. Now there is a shelf. There is a shelf on the wall. You want to place the book directly above on the shelf. Okay, students? So I'm explaining potential energy. Now you have to do some work. You have to do some work to put this, book from here to here. Let's say, students, this height is h in meters. Okay. Now, what is the weight of the book, students? Anybody can tell? Let us say m is the mass of the book. Then what will be the weight of the book? Always acting towards center of earth. Yes. If m is the mass of the book, students, anyone, what is the weight of the book? Nobody? Array, m is the mass of the book. Simply multiply mass with acceleration due to gravity, g. This will be the weight of the book. Now students, how many students agree that weight is also a force? Force exerted means force applied by earth on the book towards the center of the earth. Do you agree that mg is also force? How many students agree? Weight is also force. So that means the force acting downwards because of the mass of the book is mg. You want to take this book up. So how much force you have to apply in upward direction? Same force, mg. And this force you have to apply till how much distance? H. So what is the work done? Force into distance. Force is mg. How much distance you want to raise the book? H. This work done, students, when the books comes here at a height h. This work done is interestingly stored in the book, because work done is also energy, in the form of potential energy. You got it? So potential energy is because of position. If the book is here only, it has no potential energy, right? If the book is here, so it has half the potential energy it has here. If you take it at 2h, the potential energy will again become 2 mgh. So potential energy is because of height. Kinetic energy is because of velocity, but they are interconvertible. Let's see how. Students, now the same book at height h, this is height h, is having a potential energy of how much? Tell me. M G H. Am I right? Okay. Suppose from the shelf you drop it. You drop it. So it will drop with how much acceleration? Equal to G, 9.81 meter per second square. Am I right? When it will drop, it will get which energy? It will get which energy when it will drop?
Kinetic energy.
The potential energy gradually, slowly, not immediately, gradually potential energy will be converted to kinetic energy. Suppose students, the book comes here in the center. So it has half mgh because height is half. So its potential energy is also there. and some kinetic energy is also there, whatever is the velocity of the book under the free fall. When the books comes here, the potential energy becomes how much? Here H is 0. So any student, what will be potential energy when the book will touch the ground after falling? 0, right? But there will be kinetic energy. Interestingly, students, this kinetic energy will be equal to mgh. Means actually the formula for kinetic energy is half mv square. Whatever is the velocity. In my next video, I'm going to prove it. Whatever is the velocity, you put the value for velocity, you calculate this. This is joule. You calculate this joule. You interestingly both will be same. That means at the ground level, whole potential energy is converted to any student kinetic energy. When it is in the middle, half potential energy is converted to kinetic energy. This is the meaning of the forms of energy. Forms of energy are interconvertible, right? You know, students, you must be having a smaller brother or smaller sister. You must have slapped that smaller brother or sister so many times, right? So when you are slapping, you have your hand here. So you cannot slap if your hand is stationary. Your hand must get kinetic energy in order to slap. Means it should run. It should go with some, you have to fly your hand with some velocity. It will get kinetic energy. And let us say this is a cheek of your younger brother or younger sister. So when the slap lands over the cheek of the younger brother, some of the kinetic energy will be converted to, can anyone tell me? You will see the cheek becomes red because its temperature rises. So the kinetic energy gets converted to heat energy, some part. And if the slap is very hard, and let's say you're like a bulldozer and you are a very heavy person, you have a lot of energy. So sometimes, it can result in small damage on the, cheek of the person also, especially when you're a boxer and you box the face of a person on the, let's say on the nose will break, you'll bleed. That means the kinetic energy is converted into heat energy, as well as it has done some work on your bones also. So this is interconvertibility of energy, right? Now students, now we go and discuss what is law of conservation of energy. Students, we will define this law especially for mechanical energy, but honestly speaking, this law appeals for all kinds of energy. What are the two types of mechanical energy, students? One is potential energy because of the height of the object, and the other is, tell me,
kinetic energy
because of the velocity or speed of the object. If there is no speed, no kinetic energy. No height, no potential energy. So students, law of conservation of energy says, let us say the same example we have discussed. Let's say the book is here at height, how much? What is the height? H. At this point, what is the potential energy of the book, Adi? M G H. Right? Now, when the book is here, okay, students, this is point 1, this is point 2, this is point 3. The book is falling. This is the shelf. We just push the book and the book starts falling. When the book is here, during the fall, at that moment, we see what is the total energy of the book. It has half the energy of the book is kinetic, right? Plus half the energy is potential. Here, it has full potential energy. The complete energy is potential energy when the books falls down. Any student can comment? When the books fall down, does it have potential energy? No. Then it has full kinetic energy just before touching the ground. You might say, sir, after falling, its energy is zero. Now I'm talking about just before touching the ground. It has full kinetic energy. Full potential energy has been converted to kinetic energy. What is law of conservation of energy? It says at any moment, the total energy of the body is constant. Total energy of the body is constant. I'm going to make a video on this after this only. We're going to do some calculations also. That means what is the total energy of the body? mgh at point 1, at point 2, it is half mgh plus half m some velocity. We don't know what is the velocity, mv square. Okay? Why I said half mgh? Because the h is, in this case, the h is h by 2. So I said h by 2 into mgh. Okay? Don't think potential energy is half mgh. Here potential energy is reduced by 50%. And here half mv square. This is also equal to mgh. And students, when the book comes down, suppose this velocity is v1, v2. So let's say it's v2 at point 2. And at point 3, the velocity is v3. Students, v3 will be more than v2 because velocity will increase. So what will be the kinetic energy? Here it will be half mv3 square. Student, this expression, and this expression all are same. This is law of conservation of energy. And the last is, students, commercial unit of power. Commercial unit of power is, students, kilowatt hour. All right. How can I explain this? Let's say you have a fridge having a wattage of 1 kilowatt and it works for 1 hour. You say 1 unit of energy is consumed. Thank you very much. Complete syllabus. This is chapter is covered. Don't forget to subscribe, learn CBSE, and share with your friends. For more videos, learn CBSE. Thank you very much.